Okay, today we're going to be thinking about the Earth and its place in the solar system and how it works as a planet and how it works with the sun together to make the Earth a place where we can live. At the end of today's learning, the assignment is a quiz that I've made with 20 questions, all of which you'll be able to answer based on the learning that we're doing today. So make sure you're listening carefully, and you can always come back and re-watch this part again. This is a picture of the globe and of the planet Earth. The little circle that says UK is to help you spot the UK. It's going in the circle now. And as you can see, the Earth is rotating. The word that we use to say it's spinning is rotate. And the Earth looks like a sphere, and when we see a globe is normally a sphere, and a sphere is like a ball. And the word sphere also gives us the word spherical, and spherical is an adjective to describe something that's like a sphere. So some people might say, oh, the Earth is a spherical planet, or the sun is a spherical star. But actually, the Earth isn't exactly a sphere. The Earth has been squashed so that the top and the bottom parts of the Earth are slightly flattened, and that type of shape has a special name. It's called an oblate spheroid, and that means it's like a sphere that's been squashed. And the reason we're learning about that is because that actually has a bearing on some other of the science linked to living on the planet Earth. So again, you can see on this map the spherical globe, and then the outer line is this oblate spheroid. And again, you can see the United Kingdom on the map. So we spoke yesterday about the sun and how important it is, how it's a star and how it's at the center of our solar system. And one of the planets that's orbiting around the sun is the Earth. And the Earth, it's not really that size compared to the sun, it's just so we can see a picture, is a planet like all the other ones that orbits the sun. And orbiting means going around. It's different to rotating, which means spinning. Orbiting means going around something. So if you walked around your garden, I suppose you could say you were orbiting your garden. And normally an orbit is a circular shape. And the Earth orbits the sun in a anti-clockwise direction. So the Earth goes around the sun. It keeps doing that. It has been doing that and will continue to do that forever. And it does that over the course of 1 year. It takes 365 and a quarter days for the Earth to complete its orbit of the sun. While the Earth is orbiting the sun, the moon is orbiting the Earth. And that's because the moon's close to the Earth, or closer to the Earth, and so the gravitational pull of the Earth is keeping the moon in its orbit. If the moon was much, much, much further away, then it would probably be orbiting either a different planet or also the sun as well. And as the moon rotates around the Earth, orbits around the Earth, it also does that in a anti-clockwise direction. And then while all of that's happening, the Earth is also rotating. That means it's spinning around, and it spins in an anti-clockwise direction. So the whole time it's orbiting the sun, it's spinning around, and also the moon is orbiting around the Earth. If we look at this picture, we can see a boat, and the boat looks like it's quite far out, but it doesn't look like it's at, let's say, the very edge of the picture. If we look at the middle of the picture, we can see where the sky meets the sea, and that line has a special name. I've drawn the line in there just to show you the dots. So have a think, maybe you know what the name of that line is. That line is called the horizon, and the horizon is a line where the land or the sea meets the sky. It's not really a line. You can't go there and find the line, and if you went to where this line is on this picture, the horizon would have disappeared into the distance again. The horizon's always the furthest point that you can see. And again, that has a really important role to play in how the Earth works in relation to the sun. So this is the horizon on land. And sometimes on land you can't see the whole horizon in a straight line like this, because perhaps there might be things in the way. And also on land it sometimes seems a bit closer, because perhaps the land has some hills and some bumps that mean the horizon seems closer to you. But always thinking about the horizon being where the sky meets the land or meets the sea. And on this picture, it's really hard to see the horizon because the mountains are hiding the horizon. And so we could say the horizon is this first set of mountains, or we could say the horizon is behind the mountains that we can see in the distance. It's really hard to tell exactly where the horizon is. So when we think about the horizon, try to picture one of those pictures we saw where it's very clear and there's an obvious straight line between the sky and the land or the sea. So now we're going to move on to thinking about day and night and how those work. So again, we know that the sun is at the center of our solar system, and it's always there, and it's always burning and shining and producing energy. That's happening all the time, whether we can see it or not. And then the sun shines in all directions, but as we know, the Earth orbits the sun. And there's the Earth. Meanwhile, the Earth is also rotating. So while the Earth is rotating and the sun is shining on the Earth, we need to think about the fact that day and night is something that occurs on planet Earth, and it also occurs on all the other planets as well. So imagine the sun is shining on the Earth, and this ellipse, this yellow oval, is like the rays of the sun. You can see that only part of the Earth gets sunlight on it at any one time. The Earth rotates away from where the sun is, and so if you were standing on one part of the Earth, it will eventually rotate away and it will stop being sunny and it will start being dark. And that's why it doesn't look exactly like this, but that's why we have part of the Earth will be in darkness and part of the Earth will be in light. It's not because the sun's gone anywhere, it's because where we are on the Earth is no longer being hit by the rays of the sun. And even though the sun orbits around the Earth, we know that that takes a whole year. So it's not any different when the Earth has rotated around the sun. So perhaps, orbited around the sun. Perhaps the Earth would have orbited this far in half a year, and again we can see the sun is shining on it. It still shines on the whole planet. It shines on it at different times of the day. So while you're thinking about it being day where you live, it's night somewhere else. And really the main thing we want to better remember is that all of this is to do with the fact that the Earth is rotating and you're moving away from the part of the Earth that's facing the sun. And that happens every day, every 24 hours. And this picture just helps to illustrate that a bit more. You can see that Earth is spinning and rotating, and part of the Earth has this kind of light crescent on it, and another part of the Earth is dark. And then somewhere in between it's becoming light or it's becoming dark, and we'll talk a bit more about that now. So lots of people think that at night time the sun goes to bed, and that isn't what happens. The sun doesn't go to bed, and we know that the sun is always at the center of our solar system. And a bit like when we were thinking about whether it's day and night, we can also think about what that does for the sunset and the sunrise. So remember that this line across the middle of the screen is the horizon, and that the horizon is the land between, sorry, is the line between the land and the sky, or the sea and the sky. And imagine I'm standing where that blue oval is, and so I can see the sun. Now, as the Earth rotates, my position compared to the horizon will move. So if the Earth starts to rotate in this direction, it's like I'm moving and the Earth's appearing in front of me and getting in my way, blocking my view of the sun. The sun itself hasn't moved, and in the course of a day, the position of the Earth compared to the sun hasn't made a lot of difference. It's only the rotation of the Earth that it starts to turn, and so my view of the sun gets blocked by the horizon. And again, that will happen more and more and more until the sun disappears below the horizon. And I say the word disappears, it hasn't disappeared, there's just something in the way. The land is in the way now because I've rotated to a position where I can no longer see the sun from where I am. And then another part of the Earth has rotated into a position where they can see the sun, and so the sun would be rising in those parts of the Earth. So next time you see a sunset, try and remember that that's not the sun going down. The sun's position is staying in the same place. It's actually the Earth starting to get in the way of your view of the sun. And so eventually it looks like the sun has disappeared, but actually it's just being blocked by your view of the horizon. And then once it gets dark enough, we can see the moon. And the moon's there the whole time, but the only reason we can see it at night is because the sun is shining onto the moon. And the moon, because it has a white surface, reflects the light of the sun. And when it's dark, we can see the moon because the sky isn't as bright. Sometimes you can see the moon outside. I was just looking out my window then to see if I could see it, if it's a bit of a grey day, or sometimes if it just happens to be a certain time of the month when the moon's in a certain position relative to the Earth. But all of those things are always there. It's really just dependent on the position of the sun and where we are in relation to it. Okay. Another thing that scientists found out is that the Earth, even though it's a sphere and it rotates, or an oblate spheroid I should say, and it rotates on its axis, we imagine this axis is like a post that goes through the middle of the Earth. If you have a globe, there'll be something holding it at the top and something holding it at the bottom so it can spin. But actually the Earth's axis doesn't go in a straight line like this. It actually tilts, and when we tilt, it's like we move something from one side or to the other. And so the Earth actually is rotating, but on a tilted axis, which means that even though it looks on our globe like Africa goes straight up and down, you can see now that it's tilted off so that it leans slightly to the side, or that the United Kingdom leans slightly more to the side. It's still spinning around, but it's not spinning around with a perfect balance. It's actually rotated slightly to one side. I'm going to find out what effect that has on the weather and the climate and the seasons, and how the sun's rays are always shining, and how the Earth's position compared to the sun changes as it orbits the sun, and that the Earth rotates around and takes one day to rotate. Now, because the Earth is tilted in the way it is, at certain times of the year, the Earth in certain parts of the globe are actually away more from the sun. So if I look at this point here, it says less time in the sun. So where this blue arrow is pointing, that part of the globe isn't getting very much sun. And so that part of the globe would be in the winter. Now, when the Earth orbits the sun at a different time of the year, the Earth will be on the other side of the sun. It will made a an orbit around the sun. And now this part of the Earth will be spending less time in the sun, and so it will be winter there. And that's why it's winter in the southern hemisphere, in places like Australia or Argentina, when it's summer in the northern hemisphere, in places like Bristol and the rest of Europe. But also why there are certain parts of the world that are colder than others, because the North and South Pole get very little of the sun's direct sunlight, and so they tend to be colder, and even at certain times of the year in the northern and southern hemisphere are completely dark all of the time, because the angle of the Earth means they don't get any sunshine for a few months each year, and it's completely dark. And then at other times of the year they get sunshine all day round, and it's always light. And the last thing we're going to look at today is about the moon. So this is a picture, or several pictures, of what the moon looks like. So try and picture the moon in your mind. I've closed my eyes to try and imagine what it looks like. And when I think of the moon, I might think of the moon as being a big circle looking thing. Or I might think of the moon as looking like a crescent, which is when we have like a slice of the moon. Or I might think of a moon where I can hardly see any of it at all. And it really depends what time of the month it is as to what the moon will look like. The moon, just like the Earth and just like the sun, is always a sphere. And I said the Earth is an oblate spheroid, so I'll reinforce that. It's always a sphere, and so depending on where the moon is in relation to the Earth and the sun, changes how it looks. It doesn't look, it looks different, but it doesn't change. A bit like we said with the sunset, the sun doesn't get cut in half by the horizon. It's just the part that we can see that changes. And what we talk about when we're thinking about the moon is the lunar cycle. And lunar has to do with the moon. So when the astronauts went to the moon, they went on a lunar mission. And if you have ever heard of someone's name that is Luna, that's a name that comes from the word for the moon. So if you hear that word lunar, it's got to do with the moon. And what we call these different views of the moon are lunar phases. So when the moon is a full moon, it's like a complete circle face that we can see. Remember that it's actually a sphere. And on Saturday the 27th of February, so about a week ago, it was a full moon. And so if you'd have looked up at the sky then, the moon would have looked like a big circle in the sky. And then what starts to happen is as the Earth is rotating and the moon is orbiting the Earth, and the Earth and the moon are orbiting the sun, the position of the sun compared to the moon changes. And so less of the sun can reflect off of the moon. And so the moon looks like it changes shape. And this yellow line shows the part that's starting to look like it's disappearing, but really it's just the sun's not shining on that part. And that continues to happen, and these lunar phases continue to happen throughout the month. After about a week, it looks like about half of the moon has disappeared. It's actually called the third quarter, but we might think of it as half being visible because obviously we can see one face of the moon. The back of the moon, if you like, is not visible to us. And again, that continues to be less and less visible until we get to a stage it's called a new moon. And a new moon is essentially where it looks like there's no moon in the sky at all, or maybe you can just see the very outside circular shape that looks like the edge of a circle. Sorry, the side of a circle. But once that's happened, and again, because of the position of the sun in relation to the moon and to the Earth, the moon will look like it starts to appear again, and we start to get part of the moon appearing. This is called a waxing crescent. And a crescent shape is this shape that you see with a little slice of the moon. And again, that builds up over time until we can see about half of the moon, and that's called the first quarter. And then finally, after about another week, we'll be back to having a full moon. And that cycle continues forever. And actually, because of the amount of time it takes, people can use the moon as a helpful calendar for how long has passed between one time and another. And in fact, lots of people used to use the moon as a way to keep track of the days and the weeks and the months and the years and the seasons, and to know when it was going to be a certain time of year in order to plant their crops or to do certain things outside. And so sometimes if you look at the moon, you could maybe keep track of how it looks and how it changes and how long it takes to do that.